Okay, dear students, in the last video lecture we have seen what are the steps involved in calculating AC distribution problems. Okay, we have to consider the voltage drops that are due to the resistance as well as inductance and capacitance. Okay, and the addition and subtraction of currents and voltages are not done mathematically. They have to be done vectorially, mathematically in the sense, like generally what we do plus minus. It's not be possible. We have to do it vectorially. And there are two methods we can consider to solve these problems. One is while we take the power factor, and it will be referred to the supply or receiving end voltage. Otherwise, the second method is the power factor is referred to the voltage at the load point itself. Okay, so let us consider the first case. Methods of solving AC distribution problems. Okay, let us consider this is a distributor A, B. Okay, A is a sending end and B is a receiving end. VA, voltage at point A, is a VA, that is a sending end voltage, and the voltage at point B is a VB, which is a receiving end voltage. And you have connected two loads. One is connected at point B and another one is connected at point C. Okay, so the load that is connected at point C, let us take a load current as I1 and the power factor as cos phi 1. And the load that is connected at point B, the load current is I2 and power factor of that load is cos phi 2. And the impedance of section AC is R1 plus JX1, and section CB, the impedance of section CB is R2 plus JX2. Okay, this is what you have to remember, and it is better in the next slide I will explain everything. So better you redraw this for your ready reference. Okay, so AB is your distributor, and we are supplying a voltage or electric power at end A. So voltage at end A is a VA, which is your sending end voltage, and there will be a voltage at point B, which is VB, is taken as a receiving end voltage, and you have two loads, I1 cos phi 1 and I2 cos phi 2. And the impedance of section AC is R1 plus JX1, and the impedance of section BC is R2 plus JX2. Okay, so that's the same thing I have written here. Impedance of section AC, ZAC, as I told you, it should be vectorially. Okay, so vector ZAC is R1 plus JX1. Similarly, impedance of section CB is ZCB, which is equal to R2 plus JX2. And load current at point C, is I1, which is equal to I1 cos phi 1 minus G of sin phi 1. Okay, and the load current at point B is I2. So I2 is equal to I2 of cos phi 2 minus J of sin phi 2. You know this. No, we have, this is a vector. Vector I1 is equal to magnitude of I1 cos phi 1 minus J sin phi 1. The same thing I have written it I2 also. Current in section CB. Current in section CB is nothing but I2. Current in section CB is nothing but I2. But what about current in section IC? Current in section IC is I1 as well as plus I2. Okay. Current in section CB is only I2, whereas current in section AC is this current I1 as well as plus this current I2. Okay. So load current in section AC, IAC, is I1 plus I2. Just now I have written here. Current in section CB is ICB, which is nothing but I2. Just now I have explained you about that. And current in section AC is summation of I1 plus I2. And What is I1? Just now you have written here. I1 is equal to I1 cos phi 1 minus j of sin phi 1 plus I2. What is I2? I2 is equal to I2 of cos phi 2 minus j of sin phi 2. Okay. Now, voltage drop in section CB. See here. Voltage drop in section CB is current in this section plus impedance of this section. That is I2 into Z2 or I2 into ZCB, or you can say ICB into ZCB. Okay, same thing I have written here. Voltage drop in section CB, VCB, which is ICB into ZCB. What is ICB? ICB is, you can just, you know here, I have written here. What is ICB? ICB is I2. So I2 cos phi 2 minus of j sin phi 2 multiplied by R2. What is ZCB is nothing but Z R2 plus j of X2. Okay. Now let us calculate what is the voltage drop in section AC. Voltage drop in section AC. So what is the current in this section into impedance of this section? Okay, current of this section multiplied by impedance of this section. What is the current in this section? IAC. IAC is I1 plus I2 multiplied by what is the impedance? R1 plus J of X1. Okay, that is IAC into ZAC. Voltage drop in section AC is VAC, which is equal to IAC multiplied by ZAC. What is IAC? I1, see here, I have written here. IAC is I1 plus I2. I1 plus I2 multiplied by ZAC. So you can write it as I1 of cos phi 1 minus j phi 1 plus I2 cos phi 2 minus j sin phi 2 multiplied by R1 plus j x1. Okay, this is what voltage drop in section AC. Now, so sending end voltage. See here, what is the sending end voltage? VA. Okay, so what is VA here? VA is voltage drop in this section plus voltage drop in this section. Okay, that's what I have written here. Sending end voltage is equal to receiving end voltage plus the voltage drop in this section plus voltage drop in this section, that is VB plus VCB plus VAC, right? So the same thing I have written here. Sending end voltage is the vector sum of VB, that is the receiving end voltage, plus voltage drop in section VCB plus voltage drop in section VAC. Okay, and what is the sending end current? What is sending end current? Sending end current is current in this section. Okay, what is the current in section? I1 plus I2. Okay, I1 plus I2. Now let us draw the vector diagram. See, while drawing the vector diagram, you should remember that we are considering the power factor referred to receiving end voltage. Okay, therefore, receiving end voltage VB, this is your receiving end voltage. The voltage at this point, this is your receiving end voltage. What is the voltage at this point? VB. So VB is taken as a reference. So what is the current in current at that point? The current at this point is I2, and this I2 lags VB by an angle phi 2. Okay, because we have assumed that all the loads are inductive in nature. Therefore, current lags the voltage by an angle phi 2. Okay, same I have written here. So I2, this is I2. I2 lags VB by an angle phi 2. Okay. Now, in this section, we have current I2. So when this current flows through resistance R2, there will be a voltage drop, which is in what? which is in series or in phase, not in series, it is in phase with I2. Okay, this I2R2 is in phase with I2. Not only I2R2, you have I2 into X2 also, and this I2 X2 leads I2 by an angle 90 degree, which I have written here only. See, when the current flows in section AC, you will have I2R2 drop as well as I2X2 drop. And when you multiply these, when you add these two vectorially along with this, so what you will get is VC, the voltage at this point. Voltage at this point is VB plus VCB, right? VB voltage at point C is VC is equal to VB plus VCB, right? So VB plus VCB, this is VCB, which you will get is VC. Okay, now the load I1, at point C you have a load I1 which lags VB by an angle phi 1. Okay, see this, I have not written here phi 1, but this I1 lags VC by an angle VB, not VC, VB by an angle phi 1. Okay, now when this current flows, when this I1 and I2 flows through this, there will be a voltage drop in this section AC. What is that? I1 plus I2 R1 as well as I1 plus I2 into X1. That's what I have written here. That is IAC. IAC is I1 plus I2, right? So it will have, when IAC flows through that section AC, it will have IAC into R1, and there is voltage drop across inductive reactance, that is IAC into X1. So what is the addition of IAC R1 IAC X1 is this one, and what is this? This is VAC. So addition of VAC along with this VB and VC is nothing but your VA. This is a sending end voltage. You can see addition of VC and VAC is your VA. See here, what is VA? VC plus VAC. This is your sending end voltage. I think you have followed this. Okay, if you have any doubts, you please ask me. Okay, so what I have done here, first I have taken VB as a reference, then the current in this section CB is I2. When I2 flows through R2, there will be a voltage drop in phase with the I2, and there will be a voltage drop, that is inductive reactance. When the current I2 flows through X2, there will be a I2X2 drop which leads this I2 by an angle 90 degree. And when you add this, you will get a VC. And when you add VC with the drop of VAC, you will get VA. That's all. Understood? Okay. So see here, VB is taken as a reference. And when current flows through, what is the current? I2. When I2 flows through R2, we will have a voltage drop that is in phase with the I2. Okay. And when the current flows through this inductive reactance, there will be a voltage drop I2 or X2. And when you add these two drops with VB, you will get VC. Okay. And there will be a current VAC which flows through R1, and there will be a voltage drop R1, IAC R1, and there will be a voltage drop IAC X1. When you add these two drops along with your VC, you will get VA. So this is how you have to draw the vector diagram, and the angle between VA and IAC is phi s. That is a sending end power factor. I mean, cos phi s is a sending end power factor. So phi s is the angle between sending end voltage VA and sending end current IAC. Okay. So this is how you have to draw the phasor diagram. Okay. I think you have understood this. You please practice, you will get this. Okay? Okay, right.